Welcome to the homework help video for section 5.2. In this video we are going to be looking at 4 different problems, and all of them are going to involve the binomial distribution. I'm going to work with a little more detail on the first one that we look at, section 5.2 number 19, and I encourage you to watch this part of the video whether or not you're having problems with number 19. The reason is I'm going to explain some things in a little more detail on this first problem, and then later problems, when similar things come up, we'll move through them quite a bit more quickly. Alright, in this situation we are to assume that 90% of married women, at least the married women that we're interested in, dislike their mother-in-law, and that we have a group of 6 married women, and we're asked questions about what the probability is that certain numbers of them will fall into the group of those who dislike their mother-in-law. Now, this is the exact setup that we have whenever we're working with a binomial distribution, namely, every trial, that would mean every one of these 6 individual women, is going to be a success or a failure. Success, we will say, is the outcome that she dislikes her mother-in-law. Failure is the outcome that she doesn't. So every trial has one of 2 outcomes, success and failure. The probability that we get a success on any particular trial is fixed, in this case at 90%, and finally that the trials are independent. We don't assume that what one woman thinks of her mother-in-law much influences what another one does. Now, when we're in this kind of a situation, we have 6 trials, and any number of them, from none to all of them, could be successes. And remember, in this case, success isn't really a good thing. It's the outcome that the married woman dislikes her mother-in-law. We could then construct a probability distribution for the random variable, which is the number of women out of the 6 that dislike their mother-in-law. And I've done this ahead of time and printed it out here. I actually did this using my Excel spreadsheet, and these are the outcomes that the outcomes that are possible: 0, 1, 2, 3, 4, 5, or 6, and those are the probabilities that go with them. I'm going to show you, even though this is not asked in the question, I'm going to show you quickly how these are computed, and hopefully that'll give us a little bit of a boost to start answering these individual questions that we were asked in the problem. So what we need to do is to take a quick summary here of the facts we have to work with. First of all, this is definitely a binomial distribution. Secondly, we have n equals 6 trials. And thirdly, r is the number of successes, which varies depending on which part of the problem you're looking at. And success in this case is the outcome that the married woman dislikes her mother-in-law. R could range anywhere from 0 through 6, and we'd like to get these probabilities. Now, it's worth remembering that the probability for any particular number of R within the allowed range for a binomial distribution is given by a formula. In that formula, the probability of R successes is equal to the number of combinations of n things, n is the number of trials, taken r at a time, times the probability of a success, that is called p, raised to the r power, times q raised to the n minus r power. P, the probability of success, is in this case 90%, so 0.9, which makes the probability of failure, of course, 0.1 or 10%. Those 2 must add to be 1. Alright, so for instance, let's start, these numbers get pretty small down here, so let's start with this one over here. We could certainly compute this with the formula directly. What is the probability of 6 successes out of 6? Well, you'd say the probability that r equals 6 is equal to the number of combinations of 6 things taken 6 at a time times the probability of success raised to the r power 6 times the probability of failure raised to the n minus r power. Well, 6 minus 6 is 0. And if you remember your algebra, you can see that this actually reduces immediately to this number right here. If you don't remember, it doesn't matter. Just plug it in your calculator. You'll get this result. And 0.9 raised to the 6th power is, according to my calculator, 0.531441. Now, we could do every one of these in the table this way. We would just be changing this number here, the number of successes. For instance, here for the 5th one, I'd have a 5 here, I'd have a 5 here, and then I'd have 6 minus 5, or 1 here. These two exponents added together must always add up to 6, the number of trials. So I could do that all the way through here, but of course it's much easier to use my calculator. And for these individual outcomes of 0 through 6, those probabilities are done with the Binomial PDF function on the calculator. So let's clear this out and get restarted. We're going to access that through the distribution function, and that is right, we get that right down here. See my pointer right down here. It's just down and to the left from the arrow keys. So I want a binomial PDF function, so second distribution, cursor my way down to binomial PDF, that's choice A. Then I have 6 trials. The probability of success is 0.9. I want to know what is the probability when I have 6 successes. That's the x. Otherwise, the x on the calculator is the r in the formula. So I paste that in, and I get 0.531441, just exactly what I got with a spreadsheet, or what I got by direct calculation with the formula. Now, we can go through and compute all of these in this way. So let me do just one more, because I want to show you a quick way to do this on the calculator. Way down at the bottom of my calculator, right down here, I have this entry button. It's the same as the enter. So if I press the second key and then follow it with entry, I'll pop up my last command. And the only thing I need to change here is R, the number of successes. I want that now to be 5. That's the next thing in my list. And I get 0.354294. In other words, about 35.4%. And you can see that is exactly what's in the table. And I can do this all the way back through. So second entry, go back down to 3, press enter, and I get 1.458%, and there it is, 0.1458. I think I skipped 4. We can go back and fill that in easily enough with the entry key. Second entry, put a 4 in here for R, press enter, and I get 098415. Sure enough, there it is, and you can do that all the way through the table. We've actually, in fact, done 4 out of the 7 already. So it's very easy to construct this table, and the reason that I want to construct that is because I want to point out that we can actually, just by looking at the table with small problems like this, it's easy to answer these kind of questions. What is the probability that all dislike their mother-in-law? Well, that's the case when you have 6 successes. So the probability is 0.53, etc. So in other words, it's about 53.1%. And we're getting that direct from the table. If you want to know where we got that from our calculator, that was the binomial PDF function. 6 trials. Probability of success is 0.9, and we want 6 successes. Or, of course, you could do it with this formula, which we have sitting right here. Okay, second one. What is the probability that none dislike their mother-in-law? Well, reading from the table here, that would be 0, and I've got 0.0000. I have 5 zeros followed by a 1. So the probability that R is equal to 0 is 1, 2, 3, 4, 5 zeros followed by a 1. Now, I want to remind you of how we can write this with scientific notation. If I move that decimal to the right, let's say 1, 2, 3, 4, 5, 6, I'd get a 1, right? So this is 1.0 times 10 to the minus 6 power. And to convert back the other way, that negative means move the decimal to the left, so you'd move it 5 places, and sure enough you'd get 5 zeros in front of that 1 before you got to the decimal place. Now, the reason I'm reminding you of this is because if we run this one on the calculator, that would be Binomial PDF, 6 trials, 0.9 is the probability of success, and I want 0 successes. The calculator is going to pop up a screen display that looks a little odd if you're not used to it. So I can get that again with the second entry, but let's go through the distribution just to remind ourselves how that happens. We zoom down to Binomial PDF. 6 trials, 0.9 is probability of success. I want now 0 successes. And that gives me this strange thing, 1e minus 6. 1e minus 6 on the calculator display is to be read in this way: 1 times 10 to the minus 6. That e stands for exponent. It means the exponent on 10. So the exponent on 10 is minus 6, and there's our answer. Okay, let's look at the third part of the question. At least 4 dislike their mother-in-law. So now we're asking this question: what is the probability that at least 4, that would mean 4 or more, dislike their mother-in-law? Now, I have multiple ways of doing this. If I want to use the table I built, I could just take a look here and say, if I want 4 or more successes, that would be this outcome, and this outcome. Let's round these off a little bit just to speed up the writing. But if I take the 4, I get 0.098. Let's carry it out that far. And these are not exact, so let's indicate that. It's an approximate probability. 0.0984, and the next two are 3, 5, 4, 3 if you round it, and 5, 3, 1, 4. So 3, 5, 4, 3. And the last one, 5, 3, 1, 4. And I've rounded those off a bit, but that should still give us a pretty good accuracy. And we just add these up on our calculator. And I get 0.9841, or about 98.41%. Now, let's look back at our table here. Notice what we're doing is we're getting the sum of these 3 entries here. Now, everything added across here has to sum up to be 1, because these are all the possible outcomes. So what I know is that if I take the sum of these 3, which came out to be 0.9841, and I added the rest of them in, I'd have to get 4. That gives me a hint about another way of doing this. I could work this by complements. The probability that R is at least 4 is 1 minus the probability of its complement, or its opposite. Well, if it's 4 or more, the complement of that is 3 or less. And the reason I care about that is because I have a calculator function for that one. That is 1 minus binom. And now PDF is the probability density function, meaning that it's just giving you 1 point in the probability distribution. CDF is the cumulative density function. That gives you the sum starting at 0 and moving up to some particular place. So if I take the binom CDF of 3 for this distribution, it would be the sum of these 4 numbers here. So binom CDF, 6 trials, probability of success is 0.9, and I want to know the sum of 0 through 3 successes. And if we do that on our calculator, distribution, zip down now to choice B, binom CDF, and the trials, number of trials are 6, probability of success is 0.9. We are looking at the sum from 0 through 3, so 3 is the upper number. Run that through and I get 0.01585. And if I do that subtraction, I get 0.9841, which is in fact what we got before. It should be what we got before. What we're saying is this: if you want the probability of 4, 5, or 6 successes, you could get that by summing these 3 numbers here, or you could get that by taking 1 minus the sum of everything below. And 1 minus the sum of everything below is exactly what the binom CDF function does for us. All right, let's look at the last part. What is the probability that no more than 3 dislike their mother-in-law? Okay, no more than 3 successes would mean this: 0, 1, 2, or 3 successes. Well, that sure sounds like what we did before, and in fact it is what we did just in the previous example, only this time we don't have to subtract from 1. The sum of probabilities for 0, 1, 2, and 3 successes is binom CDF. 6 trials, probability of success is 0.9. Sum 0 through 3, and we can get that on our calculator easily. Now, on our calculator, I think with entry, we can get back to binom CDF, and 6.93, well, that's actually what we computed, isn't it? So 0.01585 is the answer. In fact, we did that last time. All right, that takes care of problem number 19 in section 5.2, and we'll be turning to problem number 21 next.